Hi all, and the next topic from the gaseous state is compressibility factor and the deviation from ideal behavior. So here before going into this topic, we'll discuss first what is ideal gas. What is ideal gas? Actually, a gas which obeys all the gas laws and the ideal gas equation PV is equal to nRT at all conditions of temperatures and pressure is an ideal gas. Okay, what is an ideal gas? A gas which obeys all the gas laws and the ideal gas equation PV is equal to nRT at all conditions of temperatures and pressures. But actually there is no such gas which obeys all the gas laws and ideal gas equation. It is completely theoretical and hypothetical. So experimentally it was evident that a real gas behaves as an ideal gas at low pressures and high temperatures. So at low pressures and high temperatures, real gas behaves as an ideal gas. And now this is an ideal gas and this is ideal gas equation. These are the conditions for the real gas to behave as an ideal gas. Now what is compressibility factor and what is the deviation observed from the ideal behavior? So if I plot a graph between pressure versus volume, actually from the Boyle's law, here the pressure is inversely proportional to volume and the plot will be like this. This is for ideal gas. If this graph is plotted for a real gas and the plot will be like this. So here this is for real gas. Now if you observe, this is deviated from the real gas is deviated from the ideal behavior. So if you observe, deviated from the ideal behavior, there is an increase in the volume. There is an increase in volume. This increase in the volume when it is deviated from the ideal behavior, increase in the volume. When this will happen? When there is an increase in the volume, if there exist repulsive forces between the gas molecules, then they move far apart from each other, so volume increases. So here if the same plot is drawn for a real gas, there is a deviation from the ideal gas observed with an increase in the volume, increase in the here more than as expected. So this deviation we call as positive deviation. This deviation we call as positive deviation. Okay, and here increase in the volume. What are the factors dominating? Forces dominating. Attractive forces are the repulsive forces. As there is an increase in the volume, here are the repulsive forces dominates. The forces dominates are the repulsive forces. Listen to me carefully. Here it is a graph plot between pressure and volume for the ideal gas as usually. If you plot the same graph for the real gas, this will be like this. So here at this point there is an increase in the volume. Here if you observe this deviation from the ideal behavior with increase in volume. With increase in volume. So increase in the volume results in here repulsive forces. When this will happen? When there are repulsive forces. When there are repulsive forces between the gas molecules, they move far apart. Because of that, volume increases. So at this stage, positive deviation, repulsive forces. What are the forces operating in the positive deviation? These are the repulsive forces. And expansion of volume, increase in the volume or expansion of volume. And if you observe this one here, it is for the real gas. Now Now here another point, volume of the real gas greater than volume of the ideal gas. So when volume of the real gas greater than the volume of the ideal gas, expansion in volume, okay, increase in the volume, that's what I have written here. Volume of the real gas greater, V real is greater than V ideal, leads to positive deviation and repulsive forces are operating. And next one, real gas. Here if you observe this point here, volume of the ideal gas greater than volume of the ideal gas greater than volume of the real gas, or volume of the real gas less than volume of the ideal gas. So when the volume decreases, here when there are attractive forces operating between the gas molecules, there is a compression in the volume. So here less than expected, so it is negative deviation. And what are the forces operating? Attractive forces. All these points are very important. Just try to focus. So here when the plot is drawn between pressure and volume for the ideal gas, this is the blue line represents the graph for the ideal gas and the red line represents the graph for the real gas. So here there is a deviation from the ideal behavior observed. So volume of the real gas greater than volume of the ideal gas. So here greater than expected, positive deviation. When there is an increase in the volume means repulsive forces dominates, and here decrease in the volume of the real gas less than volume of the ideal gas, less than expected. So this deviation is negative deviation. What are the forces dominate? Attractive forces dominate. Okay. Now next one, compressibility factor. So this compressibility factor Z here. Now compressibility factor Z. This indicates the deviation from the ideal behavior. This Z represents whether it is a positive deviation or a negative deviation, or zero deviation means there is no deviation. So here the compressibility factor Z, which represents whether it is a positive deviation or a negative deviation. Whatever the deviation is there, that will be information will be given by the compressibility factor, which is represented by Z. So the formula for Z is given by PV by nRT. Compressibility factor Z is equal to PV by nRT, and another formula is V real by V ideal. This V real will be always given to you, and this you can calculate by using PV is equal to nRT. Okay, these are the two formulae for the compressibility factor. Z is equal to PV by nRT and Z is equal to V real by V ideal. Now case 1. If Z is equal to 1, case 1, if Z is equal to 1, when this Z is equal to 1, what is Z? Z is equal to PV by nRT. When this Z is equal to 1, when this will happen? If PV is equal to nRT, Z is equal to 1. So when Z will be 1, if PV is equal to nRT, the compressibility factor will be 1. This is the case for ideal gas. You can conclude it is an ideal gas. Case 1, if Z is equal to 1. If Z is equal to 1, when this will happen? If PV by nRT. What is Z? PV by nRT. If PV is equal to nRT, then Z will be 1. Next, case 2. Case 2, Z not equal to 1. Z not equal to 1 means here PV not equal to nRT. Means it is a real gas. So if Z not equal to 1 means here there are two cases. If Z is equal to not 1, here first case Z not equal to 1 may be less than 1 or Z may be greater than 1. Okay. Z is equal to V real by V ideal. Okay. So first case Z greater than 1. When Z is greater than 1, volume of the real gas greater than volume of ideal gas. At this stage, Z greater than 1. So in that case, positive deviation. So positive deviation, volume is greater than, resulting in expansion of volume. When there is an expansion of volume, what are the forces dominates? Repulsive forces or the attractive forces? Repulsive forces dominates. Are you following? All these points are interlinked. And next one, if Z greater less than 1, when this will happen? Volume of the real gas less than volume of the ideal gas. When volume of the real gas is less, it comes under negative deviation. When negative deviation, there is a compression in the volume, decrease in the volume, compression. When there is a decrease in the volume, means which forces dominates? Here volume decreases, the gas molecules come closer, so the attraction increases. Attractive forces dominates. Attractive forces dominates. Clear? So here, what is first one? I have explained the deviation from the ideal behavior. And next one, compressibility factor Z. When this value compressibility factor Z is equal to 1, two cases I am explaining. When if Z is equal to 1, when this Z is 1, if PV is equal to nRT, then this value will becomes 1. This is the case when it is an ideal gas. Therefore, it is an ideal gas. If Z is equal to 1, compressibility factor is 1, then it is an ideal gas. If Z not equal to 1, means PV is not equal to nRT, or here volume of the real gas is not equal to volume of the ideal gas. When the volume of the real gas is equal to the volume of the ideal gas, then Z is equal to 1, it is an ideal gas. But here it is not that case. Here PV is not equal to nRT, means it is a real gas. Here two cases, if Z not equal to 1 means that may be less than 1 or greater than 1. With Z greater than 1 means if the numerator is more only, then the value of Z will be greater than 1. So volume of the real gas is greater than volume of the ideal gas. So which indicates positive deviation. From the graph also I have explained, no, this is for the ideal gas, and the second one, this is for the real gas. There is an increase in the volume. This increase in the volume more than expected, positive deviation. Increase in the volume, expansion. When there is an increase in the volume, the repulsive forces dominates. And the second case, here less than 1 happens when the volume of the real gas less than volume of the ideal gas. Less than expected, negative deviation. So tip compression in the volume. So attractive forces dominates. Okay. This is about the deviation from the ideal gas and the compressibility factor. Okay. In the next video, we'll discuss about what is the van der Waals equation for the real gas. Okay. Bye.